Hello everyone, myself is Vishwas MD. I am here to tell about the periodic table and its element. Now come to the topic. In earlier attempts to classify the element, many attempts were made to classify the known element from time to time. The earlier attempts are as follows. Proud's hypothesis in 1815. According to this theory, hydrogen atom was considered as a fundamental unit from which all other atoms were made. It is known as unitary theory. Daubigny triads in 1829 classified the elements into group of three elements with a similar property in such a manner so that the atomic weight of the middle element was arithmetic mean of the other element, which means, for example, elements like lithium, sodium and potassium whose atomic weight is 7, 23 and 39. The mean of the atomic masses like lithium and potassium divided by 2, it gives 23, which is the atomic weight of the sodium. Similarly, like chlorine, bromine, iodine, calcium and strontium are the two more examples of such triads. Newland's octaves. In 1864, Newland stated that when elements are arranged in order of increasing atomic masses, every 8 elements has the properties similar to the first, just like its musical note. This can be illustrated as given below. Sa, Ri, Ga, Ma, Pa, Da, Ni, in which lithium, sodium, beryllium, magnesium, boron, aluminum, carbon, silicon, like this. These pairs have similar according to Newland octaves. There are 118 chemical elements known to man. This is the largest number in which these elements combining to make different the compound. Understanding them can be very confusing. It is tabular arrangement of all known chemical elements according to their structural properties. Each chemical is arranged in this tabular form so we can accurately predict the properties of various elements and study the relation between them. Keep a track of newly discovered elements, analyze the chemical behavior and how two chemicals might react with each other. An element is a pure chemical substance consisting of one type of atoms, for example, carbon, oxygen, sodium, and iron. Groups and families of the periodic table. Elements on the periodic table can be grouped into families based on their chemical properties. We call them families because the elements in each families are related. Each family has specific name to differentiate it from other family in the periodic table. Elements in each family react differently with other elements. Every element has its own unique symbol. For some elements, the symbol is simply the first letter of the element's name. For example, hydrogen is H, sulfur S, carbon C. The symbol of other elements use the first letter plus one other element of the element's name. The first letter is capitalized and the second letter is not. Example: aluminum Al, platinum Pt, cadmium Cd. The origin of some symbols are not as obvious. Some elements have symbols that refer to the element's name in Latin. For example, gold Au, lead Pb, copper Cu. In modern periodic tables, some metals groups in groups and periods, the metals and non-metals and alkali metals, transition metals, rare earth metals, noble gas, metalloids, halogens, and other metals are, are arranged in different groups and periods that are shown in different colors in the periodic tables, as we have seen in this periodic table. What does the information in the box tell me? In first number that indicates the in the box, the first number indicates atomic number, which means number of protons or number of electrons, where H is the elemental symbol, and below that the number indicates our atomic mass, that is actual mass of the atoms. If you round, you get atomic masses, the number of protons plus number of neutrons. The types of elements, these metals, on the left side of the periodic table. The properties of the metals are: they are the good conductor of electricity and heat, shiny in appearance, malleable, able to molded or reshaped, ductile, able to sketch into a wire or hammered very thin. These are generally properties. Individually, properties of the metals will vary. Some will be better conductor or more ductile than others. Then we come to non-metals, the elements on the right side of the periodic table. The properties are opposite those of metals. Usually they are poor conductor of heat and electricity. They are not shiny, malleables or ductile. The most of them are gaseous. Then come to metalloids, found touching the step line, or see next slide, have properties of both metals and non-metals. The most common metalloids is silicon, which is the second most common element in the earth crust. Then we come to the periodic tables as shown in this. We can how the metals, non-metals and metalloids are um, placed in the periodic tables as shown in this periodic tables. Valence electron and reactivity. Valence electrons are the electrons farthest from the nucleus. Atoms have the different number of valence electrons. Reactivity: how like an atom is to interact or react with other atoms. Some elements are very reactive while other almost never react. Then in periodic tables, the first group elements are called as alkali metals. In this first group, the hydrogen is not a part of this family. The most reactive metals on the periodic tables. Reactive means how like an atom is to interact with other atoms. Rarely found free in nature. It forms ions with a charge of +1 and have one valence electrons. They are soft and silvery and shiny. They are very reactive, especially with the waters. They conduct electricity. The second group elements are also called as alkaline earth metals. They are still quite reactive. They form ions with a charge of +2 and have two valence electrons. White, silvery, and malleable. They are they conduct electricity. Then group 13 to 12 is called as transition metals, found freely and in compounds in nature. It forms ions with a charge of usually plus 2 but very usually with two valence electrons. Almost all are solid at room temperature except mercury because it is a liquid. They are good conductor of heat. Apart from these, some properties like they show the variable oxidation state, they form the colored ions and compounds, it have high melting and boiling point. In group 13 is also called as boron family, named after the first element in the group. Boron forms ions with a charge of plus 3 and have 3 valence electrons. The most of our laboratory glasswares containing boron with the help prevented it from scattering when heated. Aluminum is the most abundant metal in the earth crust. It is found in a mineral called bauxite. These are all some properties of boron. Then come to 14 group elements. They are called as carbon family. It contains elements that forms an unusual bond like carbon and silicon. It forms ions with a charge of plus 4 or minus 4 and a 4 valence electron. Then come to nitrogen family. It forms ions with a charge of minus 3 and have 5 valence electrons. The atomic radius increases, ionic radius increases, ionization energy and electronegativity decreases. Nitrogen family elements often form the covalent compounds usually with the oxidation number of plus 3 or plus 5. Except for nitrogen, the elements are solid at room temperature. The 16 group elements are called as oxygen family, belongs to oxygen family, also known as chalcogens. It forms the charge of with minus 2 and have 6 valence electrons. It is colorless, odorless, tasteless gases. It is readily dissolved in cold water. It is highly reactive and form oxide with almost all the elements except noble gases. The liquid oxygen is strongly paramagnetic. 17 group elements are belongs to halogen family, most reactive nonmetals. It forms with a charge of plus 1 and have 7 valence electron, including that they have very high electronegativity. Halogens are particularly react with the alkali metals and alkali earth metals, forming stable ionic crystals. Among halogen families, fluorine has the highest electronegativity. When come to noble gas, are also called as inert gases, they are non-reactive, they do not form the ions, charge is 0, have either 2 or 8 weight electrons, all of them are gaseous. They are very low electronegativity, they, they have no colors, odor and flavors, and it has high ionization energy. Rare earth metals. Some are radioactive. The rare earth are silvery, white, or gray metals. They conduct electricity. The rare earth shares many common properties. This makes them difficult to separate or even distinguish from each other. Trends in the periodic table. Atomic size decreases as you move from left to right across a table. Atomic size increases as we move from top to bottom of the table. The density of an element increases from top to bottom. The element osmium has the highest known density. The most reactive elements are groups 1 to 17. The least reactive elements are in group 18. In periodic groups, elements in some columns have similar chemical and physical properties. These similarities are observed because elements in a column have similar electronic configuration. Some amount of electrons in outermost, same amount of electrons in outermost shell. Periodic trends. Trends will be looking at atomic and ionic radius, ionization energy, electronegativity, reactivity, metallic and non-metallic characters. Let us come to atomic radius. Atomic radius, size of an atom, that is distance from nucleus to outermost electron. Atomic radius trend. In the group trend, as we go down a column, atomic radius increases. As we go down, electrons are filled into orbitals that are farther away from the nucleus. In periodic trends, as we go across a period, that is from left to right, atomic radius decreases. As we go from left to right, electrons are put into some energy levels, but more positron and electrons, totally more attractive, that is similar size. Then come to ionic radius or atomic radii. Ionic radius, size of an atom when it is an ion. Ionic radius trend. The metals lost electrons, which means more positron than electrons. So ionic radius is less when compared to neutral atomic radius. In nonmetals, it gains electrons, which means more electrons than protons. Ionic radius is greater than neutral atomic radius. Then come to ionic radius trend. In group trend, as we go down a column, atomic radius increases, and periodic trend, as we go across a period from left to right, atomic radius decreases. Then come to ionization energy. Ionization energy means energy needed to remove an outermost electron from the atoms. Ionization energy. Along the group, as we go down a column, ionization energy decreases. As we go down, atomic size increases. So easier to remove an electron because it is less attractive. Periodic trends, as we go across a period, that is from left to right, ionization energy increases. As we go down, go left to right, atomic size decreasing, more attraction, so more difficult to remove an electrons. Metals want to lose electrons, but non-metals do not. Then we come to electronegativity. Electronegativity, a tendency of an atom to attract electrons. Electronegativity along the group, as we go down a column, electron affinity decreases. As we go down, atomic sizes increases, so less attraction of electrons to the nucleus. The periodic trend, as you go across a period from left to right, electron affinity increases. As you go left to right, atomic size is decreases, so the electrons are more attra- attracted to the nucleus. Reactivity. Reactivity means tendency of an atom to react. In metals, lost electrons when they react, so metals reactivity is based on the lowest ionization energy. Where is lowest ionization energy is equal to highest I reactivity. In non-metals, gain electron when they react, so non-metals reactivity is based on high electronegativity. High electronegativity equal to high reactivity. Metallic character. The properties of metals. It is easy to shape. Maybe nuclide can be pulled into wires. They conduct electricity and heat. They are shiny natures. Along the group, as we go down a column, the metallic character increases because ionization energy decreases. In periodic trend, as we go across a period from left to right, the metallic character decreases because ionization energy decreases. So as you move from left to right, you are going from metals to non-metals. Then come to non-metallic character. The elements which have tendency to gain electrons are known as non-metals. The tendency to gain electron increases on moving across a period due to an increasing in the nuclear charge and decreasing in atomic size. Hence, the non-metallic character decreases across a period. As we move down the group, the non-metallic character decreases due to increasing in atomic size. In this yeah, picture, the entire variations like atomic radius, metallic, non-metallic character, electron affinity, and ionization energy, how it is varies in the period table along the group and group and periods that is shown in this periodic tables. So thank you.